If you had some trouble doing the 3.2a warm-up, I wanted to take a few minutes to walk through those problems with you. So we'll talk about how you got the answers that are in the Desmos activity. So the first one asks you to find the sine of 270 degrees. So the sine of 270 degrees means we are looking for 270 degrees on our unit circle, which is right here. And then the sine is just the y-coordinate. So the y-coordinate is right here. So that is just -1. Next up, we're going to find the cosine of 2 pi over 3. So we're going to look for 2 pi over 3 on the unit circle, which is in quadrant 2. And then we're going to find the cosine, which is the x-coordinate. So the x-coordinate is -1/2. Just as a reminder, I've written up at the top here what each trig function corresponds to on the unit circle. So that may help as we move forward. Next up, we're going to find the tangent of 210 degrees. So I locate 210 degrees, and the tangent is sine over cosine. So that is just the y-coordinate divided by the x-coordinate. So at 210 degrees, I'm going to take the y-coordinate of -1/2 and divide it by the x-coordinate of -3 over 2. So what I get looks something like this. -1/2 divided by -3 over 2. Now we do need to simplify this a little bit. So to do so, I'm going to rewrite this as -1/2 times the reciprocal of -3 over 2. And then we'll get rid of any giant ones. So what I have, and looking at the fact that we are doing a negative times a negative means we will end up with a positive value here, 1 over radical 3. Now finally, we like to rationalize the denominator here. So I'm going to multiply by radical 3 over radical 3 so that I end up with without any radicals in the denominator. And then that multiplication just becomes radical 3 over 3. So the tangent of 210 degrees is radical 3 over 3. All right, next up, cosecant of 13 pi over 3. So cosecant is the reciprocal of sine, which is the y-coordinate. So we're going to do the reciprocal of the y-coordinate. But we have to figure out where 13 pi over 3 is. Now this is when finding coterminal angles will come in handy. So I'm going to start with that. So to find a coterminal angle for 13 pi over 3, I'm going to need to subtract 1 full rotation. So I'm going to do that first, okay? So we're going to take 13 pi over 3 and subtract 1 full rotation, which would be 2 pi. Now, we need to get common denominators. So in order to get a common denominator, I'm going to have to multiply top and bottom of that second fraction by 3. So really what I'm doing is 13 pi over 3 minus 6 pi over 3, which is going to give me 7 pi over 3. Now that's still more than 1 rotation, so I'm going to subtract 2 pi again, which is really subtracting 6 pi over 3 again, and I get pi over 3. Okay, so what I'm really doing here is finding the cosecant of pi over 3. It's the same thing as the cosecant of 13 pi over 3. So now I'm going to look for pi over 3, which is right here, and I'm going to do the reciprocal of the y-coordinate. So my y-coordinate at pi over 3 is radical 3 over 2. So I'm going to flip that, and we're going to end up with 2 over radical 3. Now, that's not bad, except I don't like having the radical in the denominator. So I'm going to multiply by radical 3 over radical 3, and I get 2 radical 3 over 3. And that is the cosecant of 13 pi over 3. Okay, next up, let's find the secant of -5 pi over 3. Now, we're going to have to go through kind of the same circumstance here that we did in the previous problem. We kind of boxed this off here so we don't overlap. We're going to have to figure out a coterminal angle for -5 pi over 3. So I'm going to start by thinking about the fact that we're looking at a negative angle. This time, instead of subtracting a rotation, I'm going to add a rotation. So I'm going to add 6 pi over 3 based on what we did in the previous example, and that's going to give me pi over 3. So to find the secant, really what we're doing here is the secant of pi over 3. I have to find pi over 3, which we already found that a minute ago, and then I'm going to do the reciprocal of, this time, the cosine, which is the x-coordinate. So the reciprocal of the x-coordinate, well, that means we take 1/2 and flip it to become 2/1. So you can write 2/1, or you can just write 2. Either one is fine. But the secant of -5π/3 would just be 2. And then finally, we're going to do the cotangent of 60 degrees, or -60 degrees. Once again, I want to find the coterminal angle for -60 degrees. So this time I'm dealing with degrees. I'm going to add a full rotation in degrees, which is 360. So that puts me at 300 degrees. So the cotangent of -60 is the same as the cotangent of 300. So I'm going to find 300 degrees, which is here. Cotangent you can think of in a lot of different ways. Either the reciprocal of tangent, so look at tangent and flip it, or it's just the cosine over sine, or x over y. So when I'm at 300 degrees, I'm going to take the x-coordinate and I'm going to divide by the y-coordinate. Now that's going to look an awful lot like what we did up above, right? So it's going to be positive 1/2 divided by -3/2. Based on what we did in the previous example, right above here, I'd have 1/2 times the reciprocal of radical 3/2, so that's going to be -2/3. My giant ones will cancel again. Now this time it's a positive value times a negative value, so it's -1/3. And then just like we did above, we're going to multiply by radical 3/3 so that we can rationalize the denominator, and what we end up with is -radical 3/3. And that's going to be the cotangent of -60 degrees. Okay, I hope that helped for this little section. If you have any other questions, please let us know.